Hi, this is Tom, and welcome back to Lesson 28, where in this example we're going to imagine that our bookshelf got smaller. So again, suppose we have 7 books. Suppose we have 7 books, but only room for 5. How many ways? How many ways can the books be ordered on a shelf? On the shelf. All right, here we go. So just as we did in the last video, let's just with a simple picture, that's what I'm going to call this. I'm going to call this my simple picture of just slots. 1, 2, 3, 4. I have 5 slots. So notice that what happened is these last 2 slots have been removed. Okay, so we have a smaller bookshelf. Now, when you go to order the books, how many books can fit on the first slot? And the answer is 7. Or no, I'm sorry, not how many can fit, but how many could be put into that first slot. 7 books. Now, but you have 6 books remaining, so there's 6 different books that could be placed in that second slot. So you put 1 there. Now you have 5 different books to consider for the third slot. You have 4 books to consider for the fourth slot, and 3 books for the fifth slot. And by the multiplication rule, we're going to multiply these up, and that would give us our answer. Now, what we're after here is we're after, well, the number is nice, and so we can do that really quickly. But we'll come back to the final number in a moment. But what I wanted to do is, notice this, we didn't have the 2 and the 1 out over here. In other words, it's like a stopped factorial. And these stopped factorials, they actually happen quite a bit. So the stopped factorial, we call it a permutation. And we write it as, for this exact one, 7p5. And I'll show you how that works. So what had happened, if you think about what happened here, we have this problem of 7 times 6 times 5 times 4 times 3 times 2 times 1. Well, that would be 7 factorial, but we know that that's not the right answer. So what we need to do is, we don't want that 2 or the 1, so we need to divide by the 2 times the 1. Well, in the numerator now I have 7 factorial. And in the denominator I have divided by 2 factorial. And here's the interesting part. The interesting part is that 2, 7 factorial, stays the same, but the 2 actually comes from taking the 7, subtracting the 5, and then factorial. And so that would be the permutation of 7 permute 5 ways. So that's how you would use a permutation to do the problem. And let's see, the formula is this. So in general, we say n permuted r is equal to n factorial divided by n minus r factorial. And in this case, if we put this in our calculators, or we'll see, let's do this here differently. So in your calculator, you can do this as well. And what you do is you type 7, then you press math button in the upper left region. And then again, you're going to scroll over to the PR B, or on the newer ones, I think it's PROB, newer calculators. You're going to scroll over to that, then you're going to scroll down, and you'll actually see an NPR option. So you're going to scroll down to that and then press enter. Now on your screen you'll see 7, and on the older calculators you'll see NPR, and then you would type the 5 and then type enter. If you have a newer calculator, when you press the NPR, so this is the older versions and the new ones, what you'll see is the 7 will become a subscript. It'll have a big capital P, have a little block down here, and you put the 5 in, and then you arrow out of it, and now your cursor will be up above like you would expect, and then press enter. And if you've done these correctly, I think that you'll find both ways you come up with the answer of 2,520. All right, one last quick example, and that is, let's try an NBA team. An that's a B. An NBA team has 12 players. How many lineups are possible? How many lineups are possible? Well, let's take a look. So in this case, remember when a team plays, there's only 5 people on the court at any time. So we would just have 5 slots, 1 for each position. Now, remember that in basketball, we'll assume that all the positions are different because you have the, what do we have? We have forwards, the center, what else we have a power forward, a guard, and a point guard. So if we think of it this way, then we have 5 different positions. Well, when we're going to make up lineups, let's just say all of our players are about the same in all the spots. Well, there's 12 different players that could be forwards. So now you're down to 11 that could be the center. You're down to 10 that could be the power forwards. 9 could play guard, and 8 to play the power guard. And again, we would multiply this result up. Or the other way is, or you could say of the 12 positions, we want to permute 5 different players. And if we did that, we'd have 12. If you do it by hand, you'd have 12 factorial divided by 12 minus 5 factorial. Or if you do it in the calculator, and it doesn't matter, either way any of those ways you do it, you should come up with a final answer of there's 95,000. That's a lot. 95,040 different starting lineups just for a simple basketball game. And that is how we use permutations and the multiplication rule to count when order matters. Thanks for watching, and we'll see you in the next video.